Okay guys, so welcome to part 2. When I did the multi-zone, allowed it to do multi-zone grids, it gave me the error message, inflation not possible with this setting, mesh without inflation will be created. Okay, so obviously it doesn't give me more than this, so what I'm going to do is going to go mesh, inflation, I'll go on growth, and let's put that in as 20. Okay, and let's see what that does to the, okay, it's not doing anything at the moment, 20. Okay, so let's go on here and change this to 0 in there, make it smaller, and let's see if we get rid of that error. Okay, so again I had this error, but the mesh looks fine. Okay, I'm happy with that mesh. So what I'm going to do is, because the inflation is not even being used, I'll just get rid of it, and I'll generate the mesh again. Okay, so here's our mesh now. Okay, you can read more about the meshing and different types of meshing that are available in the ANSYS ANSYS manual. There's a lot of stuff on meshing, different types of meshing, orthogonality, skewness, etc., etc., etc. But we're not going to go into that. That's just too much detail. But I can leave the link to the description. I can leave the link to the website in the description. Sorry. Yeah. But yeah, let's create our name selection now. So we're going to click on edges. Click on here. That's our and right click. So you're going to click on there first. Then right click on it and then create name selection, and then you're going to go on inlet, enter, and you're going to click on here, and then you're going to right click and you're going to click on create name selection, you're going to click on outlet, and then we're going to click on this, hold the control button, click on this, right click, and then create name selection. I'm going to call this symmetry. Now some people, what I used to do is call this the wall. Now the difference between a wall and a symmetry is, if you name this the wall, you're going to get a boundary layer here. So the computer will think that this is a closed domain, and so this will be a wall, so you're going to get boundary layer here and here. But we're telling it it's not a closed domain, it's an open domain. Okay, so it's an open domain. So this flow comes in here, it goes out through here, there's nothing here and here. Okay, it's just open air. Okay. So you're not expecting any boundary layer here and here. You're going to click on this circle, right click on it, and we're going to create name selection and call it the wall, or you can call it the cylinder, either way. Call it the wall. And then we're going to go on, let's go on surface and make sure that it's, so you see it considers all this as solid. It's not, it's fluid. It's fluid. So we change that, and now we're going to go on inlet, here's our outlet, here's our symmetry, and there's our wall. So now we're ready to move on. We're going to cross this off, and we're going to go into this, okay, and we're going to right click, update. See the sign, quite intuitive sign tells you need to update it, update. Okay, so I updated it. Now you can see the setup, so you can double click on this, go into setup. We're going to go on double precision, it's more accurate. And you can read this about this again in the ANSYS manual, double precision and single, not double precision, what differences are. And I'm going to use two sort of processes. This is how many cores I think you have inside the PC. Okay, so I'm going to go on, and it's selected itself that it's a 2D, not a 3D, so you don't need to mess about with it here. It knows it itself from the geometry. So we're going to click on start. Okay. Now we are in ANSYS Solver, ANSYS Fluent Solver. Get it to load. Usually get any error messages here. If there are any error messages, click OK. And I like to keep the error messages here every time I come in. Sometimes it says click this box if you don't want it to be reminded again. But I like to be reminded because obviously I'm in the early stages of my CFD career and so I want to see these error messages or whatever, or this information pop-ups. I want to see it constantly so I can read it and get familiar with it, and then I can remove it later on. So I advise you to do the same, not to remove the error messages that come up, or the pop-ups. So we're ready now, so we're going to go on pressure-based means the density of the fluid remains constant, so assuming that density of the fluid does not the fluid does not compress, so it's incompressible fluid, you're assuming it to be. And you can assume that with air for less than 0.3 mark, 0.3 it's incompressible. Above that it's compressible. Okay. So we're gonna go on pressure based, not density based, pressure based. We're gonna go on transient, so you can see our on Kalman vortex planner. It's selected itself. We're gonna go on models. We're gonna go on scarce. We're gonna go on Spalart Alvarez. There we go. This is the model that's used for external flows and airfoils and stuff. So you can research about that. Spalart Alvarez and airfoils, and I'm sure you'll find a lot more information on it. Anyways, you can click OK, and then you can go on down materials. You can go here, fluid, air, solid, aluminium, as usual. And then you're going to go on boundary, double click on boundary conditions, double click on inlet, and let's put this in as 10 meters second. Okay. You click apply, you can click on close, and that's it. Okay, everything else just leave this as it is. And you can go down, you can go on methods. We're going to click on second order. Again, second order openscape to do with the elements and how it calculates. So second order, the nodes, sorry, the nodes and how it calculates the flow properties inside the element. So if you read about second order operand and first order operand schemes in ANSYS, you will find a lot more information on that. But second order is more accurate. Okay. So we go on now. Not report, sorry, monitors, residuals. We're going to go on, make that 10 to the minus 5. Okay. And it's hard, the smaller it is, the more accurate your results are going to be. Okay. So this is the residual. So how accurate you want the velocity, the pressure, temperature, etc. to be. To what accuracy do you want it to be? So I want it to be 10 to the minus 5 accurate. Okay. Click on OK. Go initialization. Hybrid. Initialize. It's initialized here. Okay. We're going to go on run. We're going to go on number of iterations. Okay, here. We'll click on 2000. Okay. And that's it. Let's click on run or calculate. So 2000 I'm going to run it for, and I'll let you know. That's how it goes. So let's calculate. So it's calculating now. This is the residual plot, so you see continuity, x velocity, y velocity, and the blue is the NUT. There must be some sort of parameter inside this Spalart-Armour's equation. If you check the Spalart-Armour's equation, you will find these inside it. Okay. Okay, so our calculation is complete. As you can see, our residuals did not reach the 10 to the minus 5 that we hoped for. It only reached, let's say, to the minus 3. So But anyway, to improve this, you need to improve the mesh. So it's most often now is to do with the mesh, I believe. So so you need to improve the mesh and make it more structured, let's say. Or in our mesh, you could see it didn't look as good, right? Some areas are more denser than the others. You want it to sort of grow evenly out. So you want it to be a lot better mesh. But if you improve the mesh, then you see these graphs are coming down. All of these should come down and touch at 10 to the -5, and then it say converge. So our thing did not converge as well. It just went to 2000 iterations and it ended. So ideally, you want it to converge. When it converges, that means it reached your expected residual accuracy. So click OK. Then click on graphics, double click on contours, and okay, let's cross this off. Contours. I'm going to click on velocity, click and drag, compute, display. Here we go, that's our velocity. As you can see, there's a stagnation region here where the velocity is 0, means the pressure is really, really high. So the pressure is the highest here, velocity is the lowest, 0. That's our stagnation region at the front and at the back, as you just saw in the diagrams that I showed you. And the velocity is highest on the sides, and as you can see, the flow separates, so about there. So roughly it looks the same. If you improve the mesh and stuff, it would be better. But what we can do is we can go, let's show you the pressure control also, just to confirm that. Pressure control, pressure. So I'll just click this and drag it. Compute, display. Okay, so as you can see, pressure is quite high here. And it's the lowest, pressure is the lowest here, means the velocity is the highest on the edges. Okay, and pressure is the highest here in the area where the velocity was 0. Okay, so let's go into CFD post. So let's click off this. Okay. Okay. CFD post, double click. Okay, we are in CFD post. We're going to go on contour plot here. Okay, from inlet, let's increase these to, let's say, 20. Apply. It's not popping up. Inlet. Apply. Okay, it's not. It wants to mess up. Oh, sorry. On surfaces, all domain, we go on symmetry 1. There we go. So here's our, let's go normal to it. So the other way. Okay. There's our contour. You go on animation. If you go to the top, you can't see it, but if I can't drag this thing now. But at the top here, you'll see a little clock. Okay, that says time step selector, and next to it you'll see it says animation. You just click on animation, and then you go to this from time steps, click on that and apply. But we only put in one time step. We didn't actually put in. Oh yes, we only had the one time step, didn't we? We didn't actually put in the time step that to give us the, we should have put time step as 0.001 or something like that. So we made a mistake there, but you can, when you go back to it, you can change the time step and you're able to run a simulation. Run a video. But let's see, this is the pressure control. You can see the velocity one now. Click apply. Here's the velocity one. You can view the streamlines, just here, streamline, inlet. Okay. Domain, symmetry 1, okay, and that's all streamlines, please. Okay, but anyways, I think time's running out, but anyways, I hope you enjoyed this video and you got a basic understanding of this stuff. But thank you for watching, thank you so much, and take care, goodbye.